In today's lesson, we're going to be looking at fixed point binary numbers, thinking about different data types as well. Here's our starter activity. If an integer 8 is represented as 1000, how could we represent 8.25? Traditionally, we've thought of binary as always being an 8-bit byte. So the number you can see on the screen here is actually 134. Remember, we've calculated that by 128 plus 4 plus 2. Now let's have a look at how we can represent these fixed point numbers. Now before we do this, it's important to recognise that actually representing decimals in binary is far less accurate in denary. There's no way to represent 0.2. So we can actually only get a close approximation by adding parts of a fraction together. What we do is we have the usual place values to the left. So our 1, 2, 4, 8. With new fractional places to the right. We have half, quarter, eighth and 16th. Now notice how these are the same binary sequence numbers, 2, 4, 8, 16. So for the example shown here, this would be 8 points because we've got the first 4 bits, and then we've got a quarter plus an eighth, and that gives us 0.375. This is added to the whole number part to make it 8.375. So this actually makes it quite an easy process. And hopefully you're happy with the idea of converting the whole number part at the front. So you can see in this example it would be 6, the first part. We'd put a 1 under each of the value places that we would need, so the 4 and the 2, to make the 6. The rest, we can use the same principle. So like we do in binary, we can use the subtraction method. So the subtraction method is if we're trying to make 6, well, will 8 go into 6? No, it won't, so we put a 0. 4, will 4 go into 6? Yes, it will. So that gives us a 1 there, and we can take 4 from 6, which leaves us with 2. Will 2 go into 2? Yes, it will, so we put a 1 there, meaning that we've made 6, so we can put a 0 in anything after that value. So really thinking about this, each time a place value can be subtracted, we place a 1 in that column, and if it can't, we place a 0. So let's have a look at this example. So if we have 0.8125 minus 0.5, can we do that? Well, yes we can. So 0.5, because it's a half, remember, so we can take 0.5 off 0.8125. So that becomes 1. That leaves us with 0.3125. Next up, can we take 0.25 from 0.3125? And yes, we can again. Remember, a quarter would be 0.25. So we place a 1 into that box. Next up, can we take 0.125, which is an eighth, from that value, from 0.0625? Well, no, we can't do that. So there's a 1. So we keep the value 0.0625, and we're now going to try and take a 16th off it, which is 0.0625. We can do that. So, and that actually equals 0. So it's a success in this instance. Now we've mentioned already that it's not as accurate to use fixed point numbers in binary. That's because of what we can actually use in our binary number. So we have to have a bit of a compromise. We're using all the bits as integer values. It gives you a range of 0 to 255 with no fractional values being given to increase the accuracy of the number being represented. But if we were using 3 bits for the integer part, that means that we can actually have a larger fraction section. But it means that we can only represent numbers from 0 to 7. But it does give us up to 1. Now this is the level of depth that you're going to need to go to. So what I want you to try and do now is to represent these basic numbers and complete these examples. When you're ready, you can start.